The Earth is continuously heating up. Now, no one can resist reducing carbon emissions. This is a way for us to survive, and for our descendants to survive. Our concern started here, and now we are ready to show you the solution. With this differentiated competitive edge, the innovative small modular reactor, i-SMR, will be the key player in the future SMR market. The i-SMR is a modular integrated reactor based upon pressurized water reactor technology. Single reactor module is composed of an integrated reactor vessel and a containment vessel. The pressure vessel houses all the components of the primary coolant system, including the reactor core, in an integrated manner. The containment vessel is made of low alloy steel, protecting the integrated reactor vessel and preventing the leakage of radioactive materials. One reactor module generates 170 megawatt electricity, and up to 4 modules can be installed in the reactor protection building, producing a maximum of 680 megawatt electricity. Now, let's take a look at how it operates. The primary coolant, heated in the reactor core, is circulated by the reactor coolant pumps. It is cooled through heat exchange with the secondary coolant inside the steam generator tubes, then recirculated back to the core. Inside the steam generator, the secondary coolant is converted into superheated steam through heat exchange with the primary coolant and is transferred to the turbine system via main steam pipes. The superheated steam drives the turbine to generate electricity, which is then supplied to residential areas and industrial facilities. Safety is the most important aspect of any nuclear power plant. The i-SMR's engineered safety features are full passive systems. In the event of an accident, they operate using natural forces alone, without the need for active power sources or operator actions. Let's assume an accident occurs. First, the emergency core cooling system depressurizes the integrated reactor vessel, cooling the core while the passive containment cooling system is in operation. The passive containment cooling system cools and depressurizes the atmosphere inside the containment vessel without power or operator action. The passive auxiliary feed water system uses the steam generator as a heat exchanger to remove heat from the reactor coolant system. The emergency cooling tank supplies cooling water to maintain the reactor's safe state for up to 72 hours. In this way, the i-SMR's engineered safety features operate solely on natural forces, ensuring safety in any accident scenario. Another important fact is that the i-SMR is not only for power generation, but also can be utilized in various ways as needed. It's like a multi-talented entertainer who can sing, act, and paint. Shall we take a look at each capability? The i-SMR can supply carbon-free process heat to industrial facilities that used to rely on fossil fuels. By using 10% of the steam from one reactor module for process heat production, it can supply up to 68 megawatt thermal of heat, ranging from 1 bar to 30 bar, to industrial facilities such as district heating plants, seawater desalination plants, sterilization facilities, and pulp manufacturing plants. The low temperature process heat supplied by i-SMR can also be utilized in hydrogen production facilities. By using the steam produced by the i-SMR to convert water at ambient temperature into steam at approximately 200 degrees Celsius, this steam can be supplied to the hydrogen production plant, which will then produce hydrogen through electrolysis. The i-SMR can also supply high-temperature steam to industrial facilities that require process heat at elevated temperatures. By boosting up the temperature of the steam branched from the i-SMR steam piping to over 600 degrees Celsius, significant fuel cost reductions can be achieved. The process heat provided by the i-SMR can replace heat derived from burning fossil fuels, helping achieve carbon neutrality, while also reducing costs and enhancing industrial competitiveness. Moreover, the i-SMR can also address the intermittency of renewable energy sources. With load-following operation capability that adjusts output according to demand, it can compensate for the irregular power supply from renewable energy sources such as solar and wind. With harmonious operation alongside renewable energy, it ensures a stable power supply. The i-SMR is currently undergoing standard design development with the goal of obtaining standard design certification by the end of 2028. In the early 2030s, construction of the first unit will be started domestically, and it is expected to enter commercial operation by the mid-2030s. With nearly half a century of extensive nuclear power plant operation experience, the self-development of Korean nuclear reactors and successful overseas exports, South Korea's proven nuclear technology is now focused on the development of the i-SMR. The i-SMR is set to become an innovative solution that can address both the climate crisis and energy security issues, leading the future energy market.